Hey everybody, oops. There we go. Oh, well that's still not the right thing. Let's get this back out. Oh no, sorry. I was not ready, team. There we go. Now I'm at least a little more ready. That's still not the one I wanted. Yeah, let's go to this tab. There we go. Okay, sorry about that, team. How is it going? Happy Wednesday. I'm Corey, and we're gonna be messing with some Rust hacking today. I think today we're gonna work on a little bit of a different project that I have, where we're gonna be removing the background from some videos if we can. So I have just been messing around with removing the background from videos recently and started a little project in it, and we're gonna keep doing that today. So this is using U2Net as the or U2net, I guess, is what the paper wants to pronounce it as. And basically what this does, like this paper is basically all about removing the background from things. So it's a AI model that can like basically find what is the foreground and the background, and then we're able to from there remove the background from the images. Kind of like this really fun GIF. And then, you know, here's them stitching some things together once they've done that, and all kinds of other random things. So that's what we're gonna mess with today. I have a little Rust project set up here where we are doing that for an image so far. And the other thing that we're doing is, okay, so I actually just did, so let's see if I can do this. I just added a sample MKV, which I hope I can just open. Yep, there we go. So this is gonna be me. It's actually, oh, and actually it does have audio. I didn't think it would, so I will try to, let's just mute it so that while we're messing with it, we don't do anything. And I'm going to take this frame, take a screenshot. Cool. I thought there was a better button that I've clicked before, but maybe it's that one. Did that one just put it where I think it puts it? Go up a thing, go to pictures, go to elemental video, sample MKV screenshots. Yes, perfect. Okay, awesome. And it makes a TIFF file. And I think that, well, my tool, I know it works with PNGs, so let's just convert it to a PNG. Awesome. And this is gonna be our sample.png. Did that? Nope, that's the other one. Oops, that was a client that I'm trying to not use that video of. Let's paste. Oh, it doesn't want to paste in. Okay, we will drag and drop you from here. There we go. Okay. Man, had some technical difficulties with things on screen I didn't want today. We'll have to cut the first part of this video out, maybe. Okay, but I think now if I just cargo run with my sample PNG there, and actually we're gonna, oh, well actually, one sec, before we do that, let's make sure. Okay, cool. At one point I was doing the last operation of my code 100 times last night, just as like a quick and easy benchmark. And I wanted to make sure I wasn't doing that for now. So if we run this, and remember, here is our input image, and so what it's gonna do here is, let's walk through the code. Okay, so here's our main. We set up the environment and the session, and this is for the ORT library that we are using for the model, basically. And the model and like AI stuff is a little out of my wheelhouse, but that's why this is a fun project for me. Okay, so this is ORT. This is the runtime we are using, or this is the Rust bindings for the Oinks runtime, which we are using. I wanted to use this because in theory it was gonna let me go use my GPU here because it supports running on the GPU, and it also supports Core ML, which should be what I would need to target Mac OS. But I don't actually think I'm hitting the GPU, or it might not even be the GPU in this machine, but it would be like the Mac special processing unit for this. But I don't think I am. And awesome. Okay, so I didn't get all the way through the code, so let's do that again. But this is the result, and that's what I was expecting. And it's not exactly the background being cut out, because we're trying something different that I'm calling portrait video. Kind of taking that from the portrait mode in iOS. So the idea is we take our original image, source sample PNG, and we portraitify it, which does all of the work. Okay, so here we go. We take our image in, and the first thing that we do is we resize it based on the shape of the model. So the model can actually only do square pictures at 320 by 320. So the first thing we need to do is resize it to fit that. And then we make it into an ND array. That's just because an array lets us do some processing easier and is what we want to, or is one thing that we can pass to the model. Yeah, we can use this from array here to get our input tensor. So this is probably the code that was the weirdest for me, and I guess I should mention that this is basically a Rust reimplementation of the rem background Python package. So this actually did exactly what I wanted and solved my use case. And that probably would have been it, except that I couldn't use their GPU version because they, on the same runtime, the Onyx runtime? I'm gonna go with Onyx runtime. If we got onto the hardware acceleration, nope. The install, nope. Oh, it's just this thing. Cool. So if I say that I'm on Mac and on Python and on ARM, we don't get Core ML as an option. I don't even see it at all, but it's definitely on here, some Core ML. But if we use the C one or the C++ one, then we get Core ML. So that was my plan, right? I wanted oinks for C++ or C. I wanted to use the C runtime basically, so that I could get hardware acceleration through Rust, since the Python does not support that. Great, but I don't think it's working. So if I go rust log equals ort equals debug, and then I do cargo run, and we're going to do it without release this time. What we get is this nice little message in a moment. At least I believe. There we go. So some nodes were not assigned to the preferred execution providers, which may or may not have negative impacts on performance. ORT explicitly assigns... I lost where I was reading, but that's okay. ORT explicitly assigns shape-related ops to CPU to improve performance. And then we have a dropping environment and releasing environment. Rerunning with verbose output on a non-minimal build will show node assignment. So I don't know what verbose is. I'm on debug. What's that? This is silly. Rust log levels. Trace. Let's see if it puts it at trace. That would kind of make sense. That would be verbose, right? That would be the most verbose. Get capability. Got it. That makes sense. Rerun. Nope. So it doesn't actually like, I don't know how to rerunning with a verbose output. Yeah. Okay. So if I copy this, I don't actually know how to get it to print that out. Yeah, okay, so... Oh, so I need verbose mode in this thing. So how do I set verbose mode? Okay, so is that something at the ORT level then, potentially? That's unfortunate. Because they even mention... And I believe I have CoreML enabled as a feature. I don't think... Well, I hope it wouldn't let me get that far if I didn't. Yep. ARM v8. Is the M1 an ARM v8 processor? Yes, it is. Do I want that instruction set? That sounds nice. Is that better? Where was I? Oh, here. ACL. We can add ACL and see what happens with that. So now if I go to my main execution provider ASL, right? No. ACL. Yeah, let's try that. I don't know. Ah. Looks like I don't have a supported CPU for that. That just feels like what this is. Ooh, symbol not found for architecture ARM 64. Interesting, but that makes sense. Like I didn't think I wanted that. But is CPU an option here? Because that's interesting. Huh. What does that tell me? Oh, I don't want that feature anymore though. Yeah, I still wanted that. Okay, this time it should work. Oh, hey, we got 4 viewers. How is it going, everybody? Thanks for stopping in. We are working on some AI model background removing in Rust. So we were trying to use the U2net, or U squared net, sorry, I learned how to pronounce it on stream today, to do some background removing. So we have a version, I got a version working last night before stream that works on images. Sorry, just reading this really quick. Yeah, okay, so it put it on the CPU because... Oh wait, no, that's not what it says. That's the drop. Okay, so since I registered CPU, it's not going to warn me about using the CPU. That makes sense, but I don't think it's faster than it was before. Okay, sorry about that. I started explaining and then got distracted. So I want to take a picture like this and remove the background. But when I was playing around with other tools that can do background removal, I didn't love actually having the background removed, right? Because putting another background behind it or something, it always looked awkward and it never looked that great. So I wanted to emulate the iOS portrait mode style, where basically you cut out the subject and then behind them you just put like a blurred version of the picture, and it ends up looking something like this. So I got this working yesterday on images, so you can see that, like, you know, the video of me is still really crisp, but then as we get into the background, it's got this like nice Gaussian blur and you can't actually like see the background of my video. So that is what we are going with, and what I was just trying to figure out if I could get this to run on my Core ML like on the Core ML chips on my machine here, and we're not having much luck with that. And there's a pretty good chance we're just gonna not deal with this at the moment. I think we're gonna move on, and what moving on would be is I have it working for an image, so this sample PNG. But my goal really is to do this with a video. So I want my input file here to be a video file, and then I want it to do all of the stuff to make it an output video with the background removed. Yeah, session state CC, verify each node, yep, Okay. Well, let's actually Google this really quick. ONNX verbose mode. How do you set verbose mode? Verbose equals true. Yeah, where did you set verbose equals true? Is that an environment variable, verbose equals true? That doesn't feel right. Turn on verbose logging. It doesn't even tell me how to do that though. It's just like, yeah, turn it on. Run options. Okay, so is it like a session, like, okay, so what are my options here? Dot with log level. There we go. Okay, well, now I can't even be upset about them. I did that one to myself. I just didn't even look to try to set the log level. Okay, look at that. So much going on here. Okay, okay. Add in all types of stuff. I don't really understand any of that. Oh, wait, I think I saw stuff that looked... Yes. Resize max pool. Okay. Nodes placed on CPU. Execution provider. Number of nodes 71. Yeah, well... I don't want you to do that. Oh, nodes placed on CoreML. Oh. Okay, so it... Oh, that's what I should have done, right? Is if I try it like without, if I like disable CoreML completely, is it a lot slower? I bet it will be. Let's check that out. So if I make this just CPU, is it going to be a lot slower than 26 seconds, even with tracing on? There is a chance that it actually... That took 11 seconds. That was way quicker. Okay, so is it the case that I just actually want to use the CPU runtime here? Like that it's just gonna be faster? Because that was like significantly faster, and that's not even running with release mode. That was like under half the speed that it usually takes. And I feel like there's a potential for... Yeah. Release mode just dropped that to 8. Oh, it was that I also turned off. No, I didn't turn off this logging. Okay, we are going to go with CPU for now. That's a surprising twist. I didn't even test that yesterday because I assumed it was going to be slower. Which is hilarious because I spent longer than I'd like to admit then on something that wasn't really going to help. That's kind of hilarious. Okay, so now if we just do run release, how long is it going to take to remove that background? I want this to be really quick because, well, the quicker it is, the better the video is going to be. But I was estimating at the 24-second time yesterday, and it wasn't good. Oh, so that took 12 seconds again. So I think 10-ish seconds maybe then is reasonable, but that's under half of the 24. 10-ish is much, much better than the 24. Okay. So I think we're just gonna do that, but let's get my git ignore. Oh, that's why this didn't get ignored, because it's always been a file. I forgot I actually committed that sample source. Okay, well, let's just output.png then. Let's ignore that. Oh, let's turn off log level verbose. I forgot. Now let's do cargo release. This is gonna be my best test. Oh, but it also did compiling, so it's not the best. Oh, yeah, so now it's just taking like 2 seconds. Okay, that's so much better. And let's just confirm I can delete the file. Rerun. Wait a second or two. Get this back out. Awesome. Cool. And then the other thing that I still can do that I really think could have a big impact. Always use the CPU. Crazy how much faster that is. The other thing I'm doing is right now, once I make my array and normalize the channels. Oh, and this is why I brought up this a while ago. Sorry, I'm a little all over the place today, but that's okay. Different background remover. Close, but not that one. I want this one. Yeah, this is the one. So this is the one that I'm like kind of trying to take the implementation from. So they have a few different models that they can use. So this is basically where I started looking and then converted it to the Rust that we see. I definitely found some Stack Overflows along the way, but basically what we do is they take the image and they normalize the image with these weights and this size. So the normalizing on size is doing a resize. It resizes the picture to fit in the bounding boxes. And then these are really interesting. They're what I've converted to this math here, and I have no idea why you do it. I just followed directions. So like for each channel, so for each red, blue, or green value, you do a subtraction for each pixel with the mean for that channel. So like this is, I think it's RGB in that order. So red, blue, green. So you subtract the mean and then divide by the standard deviation. I have no idea where these means or standard deviations come from. I don't really understand how they could, I don't understand what, like, I don't calculate them. These are just constants. And they're constants in this code too. So if anyone knows about, well, YouTube, U²net specifically, or even just anything about image manipulations and AI stuff, what are these magic numbers for mean and standard deviation? They don't really make sense to me. And then we do some other normalization after the fact. So this is our outputs from the oinks library thingy. So now what we do is we find the min and the max value, and we do this operation where we, do I even do this here? No, I don't. I didn't actually do these steps. I wonder why. I wonder if I need to do these steps. That also makes me wonder if I can just do this. Like, will that still work? Because if so, that's really interesting. Not like, you know, bad, but I would be very interested if this just wasn't really necessary. Yeah, I'm gonna go with not very necessary. If anything, that looks better. Except it's not zooming in, but I'm not sure that's an issue with, I think that's just an issue with my VS Code. Yeah, it's a standard, it's the high def thing. Okay, so I'm actually not gonna do that. If anything, this was better. Can I do it again? Okay, so let's actually, without mean standard deviation stuff. Okay, let's add this back in because I want to compare them. So until yesterday, I didn't have a working version of this, so I was focused more on getting a working version than trying to understand why the code's written the way it is. Open both of them. Yeah, okay, so in this specific case, I think I like the simpler version because it does a better job on the chair. I just really don't understand what is supposed to be happening by that math. It's so strange. We're gonna remove it though, because I don't understand it, but that's not the biggest deal. I mean, it just doesn't seem necessary. I'm getting good or better results without it. Let's see if I can replicate that, right? Make sure it wasn't a one-off oddity or something. No, it's still improve. It still did my chair better, so I'm gonna call that an improvement. Okay, no more normalizing. I have it committed, so I can pull it back later if I need to, because I might want to. Stop normalizing the channels before falling into U2net. I guess that's another thing that I could do. What's going on with the blame here? Okay, it was all in a commit called refactoring. So let's see, can I find those constants again? Like these numbers. Just one of them will be fine. Ooh, whoa. Which one was this one? Just because it's bigger. One thing that I don't love about the one I'm using is that it's 320 by 320, so I have to like resize things a lot. But one of those was 1024. That's a better one. Disk session. Wonder. General use oinks. ISNet general use oinks. It looks like I could probably use this one too. So I am not committing any of these oinks models to the repo because I don't have any idea if I have any rights to do that. So they don't get committed right now, which means I can't actually build this in CI at the moment, which I actually kind of just realized as I was saying that sentence live. But that's okay. We're gonna be okay with that for now. Okay, the other thing that I need to check now is, do I have 320 hard-coded anywhere? Yes, I do. Oh, okay, no, that's not what I wanted. Okay, yeah, the assert shapes, those are definitely going to be wrong in a minute if I change this, but that's okay. And this can just be shape height and shape width. I don't know which one it wants to be. I want to go width height, but I feel like I've done the opposite in a different way, so that might be a bad decision. Oh yeah, you don't need to be mutable because we didn't do that. No, we're just gonna not do this because if I'm switching it to a new one, the whole point kind of is that I'm yeah, ignore. I just didn't even want to open that file at all. So can I just like, okay, so let's rename this to output U2net, and let's just run this with this new one and see if it's better. It can do much bigger images, which might make for a much crisper background removal. Because basically what's happening is I'm taking my image and resizing it to fit in a 300 by 320 by 320 box. And then upscaling that again to be a mask that I can use for the big picture. So there's like definitely going to be some loss of quality there. I don't know if that's something with the model or what's going on there, but that's a little weird looking. But like I think it's much better than well, so one thing is interesting. Oh, interesting. Well, besides the chair's hard to ignore, but I actually, oh, see that, yeah, it does do a better job up here. Here you can see the U2net one doesn't do as good of a job on the hairline. What's this though? What's the original look like? Open source sample. Oh, there is it's just something on the bookshelf back there that just looks very strange in this. It doesn't, I think it's that it also doesn't blur 100% in that version. Yeah, see, that's a lot more blur. It's taking this as some of the foreground with my hair. But you know what, that's okay. They're very slightly different. I like that it works with both though, with basically no changes, so that's pretty cool. It's also a testament to the Python library that I'm copying all this from, because they did a very good job. Okay, well, now we can do 2 different types of model, so that's pretty fun. The other one just is standard U2 net. Yep. U squared net. Yeah, nice. Yeah, this one is much bigger sizes. We're just gonna remove this line because... But I do like that I made it work for both sizes, because that was a really good win. Support another model. It's pretty cool that that's all we needed to do for that one. Okay, so now I think we're gonna get to some fun parts. So we are going to we're gonna try to take this video. Oh yeah, we already looked at this a little bit because we took the screenshot from it. This is what we're gonna be playing with to try to do the background removal. Except this is like a 2-hour long video because this is just either last stream or a different recent stream. So let's maybe see if we can cut this to like a 5-minute video. We're probably just gonna do that with FFmpeg. First 30 seconds. Cut first 30 seconds. Specify a tart and SS start. Following would skip the first 30 and then extract that. Yeah, okay, so I can do something like this. I can just do input, copy, T, output. Yeah, okay, awesome. So input sample.mkv -t, let's do 5 minutes, so 300 seconds. -c copy, sample smaller, sample short dot mkv, because might as well keep it the same. Perfect. Let's make sure that works. Nice. And now we've got a nice 5-minute video. Awesome. Okay. Oh, what's funny? This is a behind the scenes snippet. I'm not sure what I'm doing here. But this is definitely before I actually started streaming. I don't know why I'm recording. Huh, that's okay though, not a big deal, just interesting. Okay, so the other thing that we might do today is we might translate this into a nice thing that I can post on my Today I Learned on my blog. So I've been using FFmpeg for like all of this process so far. So I actually have done the full video background removal, but I haven't done it with portrait mode because portrait mode is new to my Rust version. So I think, yeah, here's a bit like a little bash scripty thing that I wrote. And let's just walk through this and then I'll explain what we're going to do differently. So the first step is to take the video and make PNGs. So we take our input video, and I don't think we actually need the pixel format. We take our input video and we tell it to output PNGs. Um, this version right now does the entire video at once. So this is gonna dump all of the frames to PNGs. I did that with a 40-minute video and it was about 50 gigabytes of PNGs. So I don't want to do it with the full video because that would be way too much, but I can do it with my 5-minute sample because that will be much shorter. And then I'm just using the RM background tool to just remove the background from all the frames. Each frame, one by one, remove the background. This step is what I want to replace with Rust, or I want to have Rust run FFmpeg for me, but this is the bit that like I kind of already have, and we just need to adapt. Then the next thing is to make a video from the output PNGs. So this has the hard-coded frame rate that I know my video is in, or actually that I knew the video I was working with last time was in. So this is 30 this time, 30 frames per second. So we will be hopefully grabbing the frame rate from something, hopefully this is not a magic number. But ours is going to be 30 today. And then this just had some names in it. So let's remove those. Oh, and this actually does two things that I forgot about. Okay, so this one, make video from PNGs, it actually also had an overlay image that we were putting on it. I don't want that, so we're gonna remove it. And we specify a pixel format. Again, I don't know if we need that, and I don't know if pixel format works. I think pix format does. But the ones we have a video with the background removed, we can add back in the original audio track. So we give it the input of our new video and the original video and say, take the video from the removed thing and the audio from the original input, and we get our output MP4. So I looked a little bit and I didn't find any good libraries to wrap FFmpeg in like a nice, sane Rust way. What I found were some ones that looked much more C-ish, like FFmpeg next is the name of the crate, but it's not high level enough for me. Which, like, it's fine. It doesn't need to be. And it does also, while it's like the most popular, it says it's for MPEG 4 and we're on 6 now. So it definitely has some updates, but it doesn't seem to have the most. And does it have examples? Let's actually see. I didn't look too hard, I guess, at the examples. I should have. Okay, so this just looks up different encoders or something. Yeah, for arg in args. Okay, so we just we try to whatever you give it. Okay, we assume that what you give us is either a name of a decoder or an encoder, and we just dump out some info for you. Love it. But actually, dump frames. This is almost exactly what I want. Oh yeah, this might be enough for me. RGB frame index. PPM. RGB 24. So what I was gonna say was that I wanted to just call out to the CLI. And that might still be the case, because this is weird. Yeah. It's just a little too high level for me. We decoded equals a video.empty while we receive frame. Yeah, I could do it, but I just don't. I can mess with calling the CLI a little easier, I think. Ugh, but I don't like that decision. I really don't. So we get a file, we look at its metadata, streams best, yep. If it's a video... Yeah, I like this though, because frames per second has gotta be up here somewhere, right? It actually doesn't. Or it actually isn't, which is crazy. But I feel like that's something that I can get out of this. Video dot frames per second or something. So how hard is it to remux something? Yeah, okay, we're using the CLI because I need to do a lot of things and I don't want to write this kind of code. So we're not gonna. So what we're gonna do is we're gonna do more of this. We're gonna like run command line stuff, which means we're probably gonna start by just running things in the command line until we can figure out exactly the incantations we want, and then we'll move to Rust. So sample short, I want to, so this T takes a timestamp. I want to do it by 30 frames. Timecode frame set does not work. This fig is not possible. Okay. Note that cutting on exact frames in a bit stream is not possible. Okay, that's reasonable. To summarize, SS will always be frame accurate when re-encoding. Yep. If you wait, further want to encode a specific number of frames. I think I might want that. Can I just do... Can I add that to here? Okay, so let's not do the pixel format. Oh, okay, I'm just doing it here. That's fine. Oh, except it's not. It didn't paste nicely. Dash frames for the video is 60. Sample, and then it's just like, how do I that? Okay. Did that work? And I have exactly 60 frames. Wow. Okay. Yep. Are they different? Do they look different? Yep, they're not identical. That's like a second or two apart, but they're not identical. Look, how do I want to do it? Do I want to do it by frames with that? So I can't, like, I can do the first frames, that's easy. No, I don't want to do it by frames. We're going to do it by time then, because that's just what I'm allowed to do easier. Because then I can do, like, dash SS and, like, 1 minute. Right? Because this can be seconds, not milliseconds. Oh, okay, so... this is gonna be a little... I wonder, like, am I gonna get duplicates? I'm just trying to figure out how I want to do this because I didn't actually think about like the edge cases especially when I can't go by a number of frames. So SS does that. Minutes. Okay, cool. So I should be able to do 1 minute. And that should... Oh, and it just goes off the end. That's nifty. Oh, did I not give it a stop parameter? Did I just tell it to go? I did. Okay. Well, that was just going to keep running forever. Well, like, you know, oh, well, these are literally going to be the same frame just because I'm out of frame now. There we go. I'm back in frame. Yep. Okay. Okay. And then what's the... How do I stop? I can do... Seeking. Output seeking, combined seeking. Nodes cutting small sections. Yep. To capture the from 270. Okay. If used, both T will be used. I'm worried about duplicate frames. If I do 60 to 70 and then like 0 to 10, 10 to 20, like that, won't I duplicate the... No, like I shouldn't in timeline land. I guess we try it out, right? And see how it feels, and see if like if my talking gets messed up with the like audio kind of stuff. Okay, let's start doing this. Okay, so we're not gonna do portrait stuff right now. We don't even have this. Okay, so let's just do all of this commented out for the moment. Besides that one we like. Okay, I actually forget Rust system command. Yeah, process, that's what I want. Command new. Something more like this. Except it's obviously not that. FFmpeg. Okay, and then all of the options in the world. So input. We're just gonna hard code this. Then we'll short at NKV. That's not from here, it's from here. Then what? Oh, it's actually there. Nice. Okay. I think I need to do it before. So .arg -ss. No. Let's just do 0. And then where does the -t usually go? After the input. So .args, and then we can do, yep, perfect. And I do like having that be that way. Simple, short. So that I can even reasonably do the whole thing. Okay. Oh, output. That's what I need. I knew there was something I needed at the end here. We just give it a string like that. Yeah, and it actually has the single string because that's what I wanted to have. Okay, and actually, I think I also need command ::. Oh, actually, I can just do create dir all sample. I was gonna call out to make dir, but I realized that was silly. dot into diagnostic dot into diagnostic and question mark it. Okay, will this do what I want it to? Cargo run. No, it will not. It made the directory. And then it didn't do anything. Waiting for it to finish and collecting all its output. Let out equals debug out. Okay. Invalid argument. Got it. Okay. It's probably the extra quoting. I probably only needed that in bash. Yep. That was it. Nice and easy. Now we just made 300 PNGs nice and easy. Okay. And so I think what I want to do is make some PNGs, portrait all of them. So I want to do this in batches, but I need to keep... Yeah, so I think what I'm going to do is keep all of the cutout images at first and then combine in one go, but I think there might be a way to do it differently with FFmpeg, with the tool. But we will start with the simpler case, I think. Oh, I don't even know how long the video is here. Yeah, how am I gonna get, like, the information, like the metadata about my video in Rust? Or do I not and just have it do the whole thing and maybe it's not that long, but it's gonna take up some hard drive space? Well, maybe we try that. Let's get it working like that, and then we'll go on from there. So we run FMG, we make all of our JPEGs. And then what was the next step in the post? Then we do background removal. Yep. Okay, so then we for F in perfect. Boop. Dot into diagnostic. What are you? Oh yeah, that's a result. Okay. Cool. Yeah, okay. Returns the full path to the file. Full path to the file. Okay. Join. Yeah, join with... Oh, no, 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 no. I guess I could just do this. Dot... Oh, no. Dot... Enumerate. Yeah, this is the easiest way to do it. Okay. I comment F. I didn't remember which order it went. Sample... sample out. I don't know. These are awful names. We'll have to fix these. Sample out dash I dot png. I might want to do something like that. Rust format format string integer leading 0. Fill align width. 6 is what we said. That's what that one does. Okay. So that should process all the pictures. And then I guess I should put them back together too, right? Might as well. Oops. My input here. Okay, so we got some non-inputs. Dash frame rate of it's 30. Dash frame rate of 30. Pattern type blob. Yep, here's the input. Sample out. Oops, that's none of that, none of that, none of that. I learned my lesson with the other ones. That needs to be an I. I don't know if I need pix format. I don't think I do. I'm gonna not. I just don't want to do it. I'm just not gonna. Background removes that MP4. Print line. Processing frame I, yeah. I just want to see how long it takes for stuff. rm-rf sample. Cargo run release. It's a 5-minute video. We'll see how fast frames process. Oh, and this is actually not with any improvements. This is just running them without any batching. First, we're dumping all the frames. That makes sense. I'm curious. Well, actually, I'll know when it starts doing those because those will come out. I didn't really think about how long it's going to take to dump these. I have no idea. So it's 5 minutes at 30 frames a second. So 5 minutes times 60 seconds times 30 frames a second. We're looking at this to be 9,000 long. Oh, we're about halfway done then. We're almost at 9,000. And then so the only part of this that I could even theoretically speed up. Oh, and I didn't do the adding the sound back in. Oh, I kind of will. Oh, well, this one I'm not worried about the sound being added back in. I will want to do it, but I'm not worried about it here. Mostly because I didn't do any cutting up. I'm just every frame just outputting and then running it through them, which is going to be hard drive intensive, but shouldn't have any problems with duplicate frames or missing frames or getting unaligned with the audio. So like those are not exceptionally fast, right? 1 Mississippi, 2 Mississippi. It's about a second a frame, so we're talking 9,000 seconds, 150 minutes, about 2.5 hours for my 5-minute video. That's a long time. So hopefully we could speed it up by doing some batching, because this is way slow. And like, I'm assuming we got some reasonable outputs here. Yeah, look, they look great. Yeah. Boop, boop. Wow, that's wait, one frame. I go from there to there to there to there. Oh, I don't know that these are ordered. They're not ordered. That is pretty funny. I didn't think about that. I don't actually care to do that. Okay, so path. Let file name equals that. That'll work. Oh, file name unwrap. Yeah, I don't, yeah. Into diagnostic. Oh, I don't know what this is. Let's unwrap it. Oh, it's an option. It's an option. No, it's definitely gonna have file name. RF sample and sample out. Ah. Oh, that's reasonable. Okay. S string. Two string? Two string. Right, there we go. Oh. Huh. That is borrowed for a few of those places. That's interesting. Oh yeah, because I borrowed it for file name. That's so interesting. Wouldn't have thought that was gonna matter. If I do it in the other order, does it? Does it? Like if I get file name after we do that? Yeah, now we can't use it. Oh. Just take a reference to the path. You don't need the whole thing. Yeah, there we go. That's why it was weird. Okay. I didn't make it any faster though, so like I don't really know if this is super useful to do. Because it took a little while, and I guess I could have just left them there and commented that part out. I guess I'll probably do that next time. Yeah, just that directory. Yeah, it only takes like a minute or two though. It's not awful. Wonder how big the folder gets though. Oh, no tmux anymore. I used to do tmux, and I've recently tried switching to do it without tmux. And it's fine. I'm not used to it yet. I should make sure I have the keyboard shortcuts working for sorry, for VS Code. Since that's what I use for my terminal now. Whoa, 11 gigs for the 5-minute video? Man, I guess that was 24 versus 30 frames a second. And this is 1080p versus 720. Yeah, so I'm gonna have to figure out something to do though, because if a 5-minute video is 11 gigs of sample, and that's okay. No, it is at least not before it starts processing frames. It's pretty interesting to me the order it goes in, which is why that I thing was not going to work. Yeah, we're just gonna need to speed this up. Sample out. Oh, it works though. Works great. So let's make a commit. My commits are very bad, so I'm probably gonna have to go in and clean them all up eventually. Star.mkv. How about that? Yeah, perfect. Get FFmpeg CLI called from Rust. Not very exciting because it's using the CLI, but it works. Okay, so reader, except I don't need to enumerate anymore because I don't need that. Because this can really just say file name. Like, I don't need it to say anything else. Processing frame file name, love that. Yep, doesn't need to be in order. I just wanted to have some idea that stuff was happening. Except I guess I'm about to chunk this, so. Rust, itertools. Chunks. Perfect. Chunks what I want. Into chunks is iterable only by reference. You can also call into iter explicitly. Okay, that's fine. Cargo add itertools. Chunks of like, I don't know. Start off with like 10 maybe. Reload the workspace so that it'll pick up, there we go, pick up that for the import. Yeah, I know. Okay, yeah. So what I really need at the end of the day, so besides like, well, I do need the file name stuff. So I want to say let images equal f dot iter dot map f image open reference to f dot unwrap. Unwrap collect vec. The trait, oh, it can't be made into a path. That's so funny. Okay, perfect. Okay, so these are the images. So really what I want to do is say something like let portraits equal portrait session images. I guess this could be portraits just to give myself a new one, but I think it's gonna end up being, it might just be easier just to replace it. We're just gonna make this portraits, and then this becomes a reference to a slice of dynamic images. Perfect. Because really what I'm trying to do is it's in cutout that I want to parallelize these. Yeah, so in cutout images, cutouts. Yep, okay, so let's go to cutout. Original images. Can it be a reference to a reference? Yeah, it can. Dimensions. No. Oh, it's actually a bit easier now because I got rid of some of this stuff. Where do we need original dimensions for? We don't need you for a minute. So let inputs equal original images dot into iter dot map image, or original image can go here, sure. Dot collect to a vec. Okay, that actually is fine because it's just a vec of nothing. That's funny. It's a vec of input tensors. Okay, so and then wow, that was way easier than I expected it to be. Images at 0, just like grab the first one to do yeah. We no. We know that all the images are frames of the same video, so we'll have the same dimensions. Oh, I need image buffer here. Got it. Okay, so resized dimensions though. When do I need resized dimensions? Okay, so this is another hack. To fix this hack. The resize dimension is not the same as the original dimensions. This is because the model expects a square image and a small one. This is a dupe of work from inside the loop, but hopefully the batching is enough benefit to justify it. That works for me. So that's inputs. Inputs. Nice. Okay. A vec of RGB images. outputs dot map. Let cutouts equal output. Oh, this needs to be what are you actually? You're a vec into iter. When we map on it, we're gonna collect vec at some point, and that's gonna return that. Okay. Outputs. Oh, that's that other outputs. Cutouts. That's what I named that. That's a better name anyways. Open cutout. Oh yeah, okay. What if so I think I want original images zip with outputs. Wait. It's not an iterator. Iter. Perfect. Oops, inside here, original image, and then the output. We also need this line. Okay, so this is actually gonna collect. That's an okay of a cutout. This is gonna be a result of a vec of something. Just let it be. What's a might result? Yeah, there we go. Wait, is the then I just return cutouts? Oh yeah, no. Collect dot into well yeah. Into diagnostic. Wrap it. Oh no, I can just return cutouts. Cool. Fair. No double reference. Expected found. Oh, okay. That's fine. I'll just undo that. I don't think this cares. Cool. A echo dynamic images. So then I want to do original images dot iter dot zip with the cutouts dot map it where we have original image and cutout. Yeah, okay, so we're missing some steps here, but that's okay. It's pretty close. So we blurred. Yeah, we just want this whole thing. Cool. Okay. Chunks of like 100. Sure, let's do that. Okay, so now we have our images, and we have our portraits. Images.iter.zip with portraits. I've been really liking zip today. I don't need a map here for ridge from a portraits in that, right? Yep, awesome. Oh wait, do I want a ridge? No. I want file in f.iter. It already is an iter. Yep. Yep. File. Oh. That shouldn't do that though. Oh, actually, I shouldn't need an engine diagnostic there. It already is one. Ref? By ref? No. Can I clone the chunk? Yeah, I didn't think so. Yeah, right? I don't understand what that's telling me. Oh, unwrap. I can't unwrap on a reference. Okay. Wait, I can't close. Oh, okay, yeah. Well, that's really interesting. Map x.unwrap. There we go. Okay. No, I can't do it after entries. I don't need that there. That's the thing I needed. There we go. Phew. Okay. I think that'll work. We're gonna try this in things of 100. See if this is like substantially faster. It would be really cool if we just could process like hundreds of frames in about the same amount of time. Ooh, blow up. Not matching number of inputs. Oh. Dang. Okay, I didn't realize that was what that was telling me. The model only knows how to do one at a time, so this batching isn't helpful. Wow. That was a lot of work to get to that answer. And I think I just want to revert it all, right? Because it's just not... Ugh. Oops. Model only supports one at a time. Get revert head. I liked it better when it did it this way. Processing file name. Yeah, we don't need the I. Drop surrounding. Get rid of the enumerate. Yeah, awesome. So I think this will work. It's not gonna be exceedingly fast, we realize. But I think it's gonna work. I actually wonder which one of these is faster. I wonder if this U2net's a lot faster. That would be very interesting, wouldn't it? I wasn't timing them when I was dealing with that. RM, RF, sample out. Especially because using a new model. I bet they both only support one at a time, but I didn't think to check. Okay, so this is faster. I'm not sure it's as fast as I'd like it to be in any sense, obviously, because I'd love it to be like really, really quick, and it's just not gonna get there. Oh, cool. When I am gone, we don't get any blurring, which is fine. Just was curious what was gonna happen. Yeah, okay, so this is definitely running. So how can I count files in directory? Count files in dir. Bash. Perfect, that was easy. ls sample word count lines. Okay, perfect. Like this is the easy way. Oh, okay. Not very many. How long do we think it's been running? Do we have any idea? Not really. Oh, when did I start this? 43, so it's been maybe 2 minutes. So we've got about a frame a second or something, which is still about the same as what I estimated before. 9,000 frames, that many minutes, that many hours, and this is for a 5-minute video. Because it's just 30, it's just the frame rate time, so if I have a 5-minute video times 30 minutes, yeah. Yeah. Is this rolling with release? I think so. Yep. Yes, it is. And that's definitely faster than 1 a second, but it's not like 2 a second either. Oh, we got .png files. That's always good. You need to have .png files. I actually kind of thought file name wasn't going to include extension, but apparently it does. Okay, and I think we are going to wrap up there for the day. We got something that I think will process the whole video in, like, through Rust. You know, we just give it an input file and it will get to the end. We are still doing the full frames at a time thing, and we're not chunking that, so it does mean that you need the full hard drive space for both the original frames and then the portrait mode frames, which for this is going to be like 22 gigabytes for this 5-minute video. So definitely things to improve on in the future. Would really like this just to be streaming, right? You stream in a frame, you stream out a frame. But I'm not sure how to pull that off. But anyways, this was a good stream. We got some good stuff done. We definitely, you know, these sample files are looking great. We will stitch them together at some point here, and we will have a working video, hopefully. Yeah, some of these are funny. Like that, it doesn't always do the best, but I'm curious to see what a video of it looks like, right? Like, what does 5 minutes of this look like? Does it look bad? Does it look reasonable? We don't know yet. Okay, so we've got to almost 500, and it's been a few minutes, so that's an 18th. I guess that's fair. 9 times 2. So like even 20. So even, yeah, it's gonna be a bit. It's gonna be a bit. Okay, well, I think that's an even better reason to wrap up for the day. Thank you for coming and hanging out with me, team. I always appreciate it, and I hope you learned something, or at least enjoyed hanging out. I will definitely eventually publish this RM background tool, but I think I want to iterate on it a few times before then. But if you hang around stream more, I definitely think we'll work on it again and get it open sourced here soon. And with that, I think I'm gonna head out of here for the evening. Have a good rest of your Wednesday, everyone, and I'll see you around the internet soon. Thanks. Bye.